Astronomers have found clear evidence of what could be an Earth 2.0. This artist rendering shows the rocky planet identified as Proxima B orbiting the Proxima Centauri star.
The James Webb Telescope recently made a discovery that totally shocked scientists. This find has got everyone asking, could there be life on other planets? The telescope was focusing on Proxima Centauri B, the closest star to Earth, when it spotted something strange. It was giving off unusually bright lights, almost like the glow of city lights. But what could be causing these lights on Proxima Centauri B? Could this be a sign that life exists beyond Earth? City lights in space. People have been wondering about life in space for ages, and scientists have been searching for any kind of proof for years. We've always been fascinated by the idea that we might not be alone in the universe. The idea of finding signs of life outside our solar system seemed like something straight out of science fiction, but now it's getting closer to reality. This discovery has everyone excited and curious to know more. The thought that there might be living beings out there is thrilling, and any evidence that suggests it's true has been welcomed with open arms. What makes this even more incredible is how unexpected it was. The team working with the James Webb Telescope wasn't planning on discovering city lights in space, especially not from a star that's so far away. This breakthrough is a huge deal because it's one of the first solid signs that life could exist elsewhere. For years, scientists have been waiting for something like this, a solid, tangible sign that life could be out there. And now, it seems like we're closer than ever to understanding whether we're alone in the universe or if there's something more out there. If it turns out that these lights are actually coming from an intelligent civilization, it would mean that societies in space could be way different from anything we've ever known. The thought of civilizations out there, just waiting for us to discover them, is both thrilling and mind-blowing. The idea that these city lights have been sitting there for who knows how long, waiting for the right technology to spot them, is almost unbelievable. NASA engineers, when they saw these lights from 7 trillion miles away, couldn't help but wonder just how long they've been shining. How long have these mysterious lights been visible but unnoticed until now? It really makes you think about the vastness of space and how much we still have yet to discover. David Kipping, a scientist at Columbia University, explained that Proxima Centauri B is difficult to understand, especially with the strange city-like lights. The heating patterns on this planet don't match those on other known worlds, which only adds to the mystery. It's unlike anything we've seen before. The fact that these lights seem to indicate some kind of civilization challenges everything scientists thought they knew about planets and life beyond Earth. If these lights are indeed from an advanced civilization, it opens up a whole new chapter in space exploration. Exploring Proxima B. It's well known that most rocky planets take in sunlight and release infrared energy, but Proxima Centauri B is different. Its infrared signature doesn't match what scientists expected from a planet orbiting its star, Proxima Centauri. That's where the James Webb Space Telescope came in. It was the perfect tool to study this strange planet. The telescope is equipped to capture infrared light, and that's exactly what it did. Proxima B's unique heat signature could reveal a lot about its atmosphere, and scientists are eager to dig into that mystery. Infrared bands are one of the telescope's specialties. It can detect heat that's invisible to the human eye, and it's especially good at picking up on things like the temperature of distant planets. This technology is a game changer because it helps scientists study planets that are so far away we can't physically visit them. Proxima B, which is located around 4.2 light-years away from Earth, is an ideal candidate for this kind of research. By examining its heat signature, the telescope could uncover details about the planet's atmosphere, what it's made of, how thick it is, and whether it could support life. This is important because Proxima B is in the habitable zone of its star, meaning it could potentially have conditions that allow for liquid water, a key ingredient for life. Scientists are particularly curious about whether this planet could sustain life, so they're hoping the infrared data from the telescope will help them figure that out. If Proxima B has an atmosphere that could support life, it would be a huge step forward in the search for life beyond Earth. The telescope's advanced infrared imaging could give us a clearer picture of whether there's a chance for humans or other life forms to one day visit, or even live, on this extrasolar world. Most space cameras struggle to pick up the faintest rays of light across the vastness of space, but this telescope can see even the tiniest glimmers. This makes it the perfect tool to check out reports of city lights on the nighttime side of Proxima B. If those lights are real, the telescope will be able to spot them, as long as the lights fall within a certain frequency range, about 1,000 times smaller than sunlight. What's really fascinating is that Proxima B's surface and its star, Proxima Centauri, create some interesting conditions. On the day side of Proxima B, there are plenty of solar features that collect energy from the star's beams. These solar panels or screens help absorb and store the energy, but they also reflect light back into space, making the planet's surface even more intriguing to study. As Proxima B orbits around its star, it experiences day and night cycles, similar to Earth. During the day, the sunlight heats things up, and at night, things cool down. It's a basic cycle we know well, but what makes Proxima B so interesting is how its temperature changes in response to these cycles. This temperature variation is key for scientists because it can provide clues about the planet's atmosphere and how it responds to its star's energy. The telescope's ability to pick up infrared radiation from the planet will help scientists learn more about how Proxima B works, especially during its night phase when it's in the shadow of its star. Proxima Centauri B could have some extreme temperature swings between day and night, depending on whether it has an atmosphere. If this planet doesn't have one, the difference would be huge. The day side would be blisteringly hot, like the surface of a black body, while the night side would be pitch black and freezing cold. That's because without an atmosphere or any kind of protective layer, there's nothing to regulate the temperature between the two sides. It's pretty crazy to think about. But if Proxima B does have an atmosphere, that could change everything. Astronomers are really interested in studying how much the temperatures change on this planet, because it could reveal a lot about its atmosphere. One of the key tools they're using to learn more is the James Webb Space Telescope. It can quickly analyze the heat emissions coming from the planet, providing scientists with useful info about what Proxima B's atmosphere might be like. Thanks to its ability to detect infrared light, the telescope can pick up on details that other instruments might miss. This gives astronomers a clearer picture of the planet's climate and whether it could possibly support life. One thing that's interesting is that the telescope's orbit around Earth lines up nicely with Proxima B's orbital period. This means the telescope can fully observe Proxima B's day and night cycles, which last about 11.2 Earth days. That's a pretty good amount of time to gather data and make observations, especially since Proxima B is so far away. By watching how the planet's temperature changes over these 11.2-day periods, scientists can get a better sense of whether the planet's atmosphere is thick enough to handle those extreme temperatures. If Proxima B does have an atmosphere, the next step is to study its chemistry. Gases like oxygen, water vapor, and methane are key indicators that a planet could support life. These elements are essential for life as we know it, and their presence would suggest that the planet has conditions that might make it livable. But finding these gases isn't easy. Scientists have to pay very close attention as they record and study light rays passing through the planet's atmosphere. By analyzing how the light changes as it moves through the atmosphere, they can figure out what gases are present. While the James Webb Space Telescope has made incredible strides, there's still more to be done in exploring distant worlds. Future of planet exploration. Even though the James Webb Space Telescope is amazing at describing the atmospheres of distant planets, it has its limitations. One of the biggest challenges is that it's not great at detecting bound oxygen, which is a key indicator of life. Oxygen in a planet's atmosphere could suggest the presence of living organisms, so it's something scientists are especially eager to find. But even with this limitation, the telescope can still search for other signs of life, like ozone. Ozone is another important marker because, like oxygen, it's often associated with biological processes on Earth. Despite these challenges, the James Webb Space Telescope is still one of the best tools we have for studying exoplanets and their atmospheres. The only downside is that it can only study a handful of the closest potentially habitable planets to Earth. But there's hope on the horizon. In 2028, the Extremely Large Telescope, which is a ground-based telescope, will start its work. The ELT will be able to dive even deeper into the atmospheres of faraway exoplanets and gather more detailed information about whether they could be suitable for life. This telescope will be a game-changer for astronomers, as it will help them understand the habitability of worlds that are much farther away than those the James Webb Space Telescope can currently study. Until the ELT comes online, the James Webb Space Telescope is still a crucial part of our exploration efforts. It may not be able to find everything, but it's still our best tool for uncovering the mysteries of faraway worlds. The data it gathers will continue to shape our understanding of how planets form, how they develop atmospheres, and whether they could eventually support life. The main goal for the next generation of telescopes is to reduce the bright light coming from a planet's host star. Right now, the intense light from the star makes it hard to see the faint light reflections from the planets themselves. So, to improve visibility, scientists are working on ways to block out that star's brightness. They plan to use special internal masks or big external satellites that act like shields, similar to how you might squint or cover your eyes to block out the sun and see better. Once they can filter out the star's light, future telescopes will have a much clearer view of the faint light reflecting off exoplanets. This will make it easier to study the planet's atmosphere and look for signs that it might be habitable. With less light pollution from the host stars, these telescopes will be able to dive deeper into understanding whether these distant worlds could support life. This is huge because it could help us answer one of the biggest questions in science. Are we alone in the universe? However, there's still a lot of work to be done. One of the challenges is figuring out how to distinguish between gases that come from living organisms and gases that are produced by natural processes like volcanic activity. For example, volcanoes can release gases like carbon dioxide and methane, but these gases aren't necessarily a sign of life. So, scientists will need to be careful and develop methods to tell the difference between gases that might indicate biological activity and those that come from non-living sources. As we continue to make breakthroughs, the question of life beyond Earth is more pressing than ever. Life beyond Earth. As we keep exploring space, we're learning more about how the universe works and where we fit into it. Scientists have been searching for answers for decades, but even with all the advances in technology, they still haven't found solid proof of life beyond Earth. That hasn't stopped the search, though. The big question still lingers. Are we the only ones in the universe? This search for other forms of life has been around for a long time. People have been wondering for centuries if there are other beings out there, maybe even civilizations waiting to be discovered among the stars. Today, scientists are using advanced tools like the James Webb Space Telescope to look for signs of life on distant planets and even hidden alien societies that might be out there. The idea of alien life has captured our imaginations for years, and the search continues with the hope that one day we'll find concrete evidence that we're not alone. One of the key organizations behind this search is the SETI Institute, founded in 1984 by two American scientists, Jill Tarter and Thomas Pearson. SETI stands for Search for Extraterrestrial Intelligence, and their mission is to search the universe for signs of alien life, specifically looking for radio messages coming from space. Radio waves are interesting because they can travel across vast distances without getting lost or absorbed like other types of radiation. This makes them ideal for long-distance communication, and scientists believe that if intelligent life forms exist, they might use radio signals to communicate. Despite SETI's efforts over the past 30 years, they haven't yet found any solid proof of alien signals, but Jill Tarter, one of the founders, isn't giving up hope. She believes that with the help of new technology, the search for alien life will accelerate. In fact, she thinks the key to finding these alien friends is to get the whole world involved in the search. The more people looking, and the more advanced tools we have, the higher the chances of making a groundbreaking discovery. As the search for extraterrestrial life intensifies, the James Webb Space Telescope is playing a key role in uncovering the universe's secrets. Exploring the universe with Webb. The James Webb Telescope is specifically designed to find out the tough details about galaxies, planets, stars, and even how space first started. Using its advanced camera and filters, the telescope can separate different wavelengths of light, which helps scientists study the chemical and physical makeup of objects that are way out there, far beyond our reach. One of the things the James Webb Space Telescope is always on the lookout for are tiny signs of life on distant planets. It's a huge part of understanding some of the most intriguing mysteries of the universe. For instance, it helps scientists uncover things like the amount of mass in galaxies. It turns out there's a lot more mass hidden in massive galaxies than people thought, and this discovery has made us question more about the shape and size of the early universe. It's kind of mind-blowing how much we're still learning. Just 20 years ago, we didn't know much at all about what's out there beyond our solar system. But now, astronomers have discovered over 4,000 exoplanets, which are planets that orbit stars outside of our solar system. That's a huge leap. It shows just how far our curiosity and technology have taken us. With each new discovery, we're getting closer to understanding not just the makeup of these distant worlds, but also the potential for life beyond Earth. NASA believes the recent discoveries are just the beginning when it comes to space exploration. According to scientists, there are trillions of exoplanets out there that we haven't even discovered yet. Even though scientists have been searching space for decades, they're still hopeful about finding alien life in places humans have never been. There have been moments when it really seemed like we were getting closer to finding something, like when the Galileo spacecraft visited Jupiter. It sent back data showing a unique set of wavelengths, which gave scientists a new hope. Plants could potentially grow on other planets. This was a huge deal because it was the first time they had found a biosignature, which suggests that life might exist somewhere beyond Earth. This biosignature, known as the Vegetation red edge, was a game changer. It's a sign that life, specifically plant life, could be present elsewhere in the universe. The way it works is by closely examining how light bounces off surfaces to spot signs of vegetation. This is a key method in identifying life on distant worlds. Now, with the James Webb Space Telescope, scientists hope to take it even further. They want to map out the characteristics of planets in the habitable zones around their stars, where conditions might be just right for life. By understanding the orbital parameters of these planets, scientists can gather crucial information about whether or not these exoplanets could support life. New frontiers in the search for life. Earth is starting a new journey to uncover more of the universe's secrets, and a big part of this adventure is looking at how sunlight interacts with the atmosphere of distant planets. When sunlight passes through the layers of an atmosphere, the atoms and molecules in the atmosphere absorb the light in different ways. This light is broken up into wavelengths, and by studying these wavelengths through spectroscopic research, scientists can figure out what the light tells them about the planet. It's kind of like how a fingerprint can uniquely identify a person, but instead, the light gives us clues about the planet's atmosphere. People often think the new space telescope will mostly be able to pick up light from stars as it interacts with a planet's atmosphere. What's exciting is that this telescope might just be the key to figuring out what exactly those atmospheres are made of. For planets roughly the size of Earth, it's common to find gases like carbon dioxide, nitrogen, and oxygen in their atmospheres. And these elements could suggest that life, like what we have on Earth, could exist there. However, it's also possible that if these planets lack certain chemicals, it could mean that life on those planets might be completely different from ours. One interesting thing scientists are looking for is man-made chemicals like chlorofluorocarbons, which are used in cooling and industrial processes here on Earth. If the telescope happens to detect chlorofluorocarbons in the atmosphere of an exoplanet, it could be a huge indicator that there are advanced societies out there, beyond our solar system. This would be a game changer, as it would offer solid evidence that intelligent life exists elsewhere in the universe, possibly in civilizations much older and more advanced than our own. The idea of life beyond Earth is often tied to biology as we know it, which typically focuses on the idea that life thrives in temperate areas with Earth-like conditions. But the truth might be way more complicated than that. For example, extremophiles, organisms, mostly bacteria, that can live in harsh, extreme conditions, are pushing the boundaries of what we thought was possible for life. These hearty organisms, known as extremophiles, are pretty incredible. They can live and thrive in conditions that would make humans cringe. For example, they can survive in environments as hot as 250 degrees Celsius, and in places where the pH is so low, it's nearly acidic enough to burn your skin. The fact that these organisms can not only survive, but actually grow and multiply in such extreme conditions shows just how adaptable life can be. They're a perfect example of how life can endure even the harshest environments, and this opens up a whole new way of thinking about the possibility of life in the universe. Considering how huge the universe is, with so many different types of environments, it's clear that our search for life beyond Earth needs to be wide and varied. It's not just about finding planets that are exactly like Earth. Planets that resemble Earth and orbit stable stars like our Sun are ideal places to study. But scientists are also starting to think about exploring planets around other types of stars, like red dwarfs. Red dwarf stars are really common in the universe, and even though they're cooler and not as bright as our Sun, they still offer a lot of potential for discovering life. These stars have incredibly long lifespans, which means they give plenty of time for planets around them to evolve and possibly develop life. This opens up a whole new area of study for scientists. One of the coolest discoveries in this area was the finding of a new planetary system called TRAPPIST-1. This system has been making waves in the scientific community because of how similar the planets there are to Earth. TRAPPIST-1 is a red dwarf star system, and it's made up of 7 rocky planets that orbit the star. What's exciting is that 3 of these planets are in the habitable zone, which means they're the right distance from their star to possibly support liquid water on their surfaces. Since liquid water is one of the key ingredients for life as we know it, this makes these planets incredibly interesting for scientists searching for signs of life beyond Earth. The Sun here on Earth is bigger and hotter than the star at the heart of the TRAPPIST-1 system, but the light from TRAPPIST-1 is still interesting to scientists. Despite being smaller and cooler, TRAPPIST-1 gives off a soft light, a bit like the sunlight we get on Earth, which could be key to understanding whether life could exist on the planets in this system. Scientists have been studying the light from TRAPPIST-1 very closely to try to figure out the conditions that could make the planets there habitable. The study of the entire TRAPPIST-1 system was a huge breakthrough, revealing that the system, which includes 7 planets, is located about 41 light-years away from Earth in the constellation Leo. The research team, led by Ward Howard from NASA, was thrilled with what was revealed. Howard pointed out that for the first time in history, we could actually look for planets around other stars that have atmospheres similar to our own. This opens up a whole new world of possibilities in our search for life elsewhere in the universe. Howard also emphasized that studying exoplanet stars is essential for understanding the planets and solar systems that orbit them. There are billions of stars scattered across the universe, but one that stands out because of its proximity is Proxima Centauri. This star is only 4.25 light-years away, making it the closest star to Earth after our Sun. While it's close in cosmic terms, Proxima Centauri's light is so faint that it's nearly impossible to see it with the naked eye. If any planets orbiting it were to be habitable, they would need to be much closer to the star, about 20 times closer than Earth is to the Sun. In 2016, astronomers made an exciting discovery about Proxima Centauri. They found a planet, named Proxima B, that's about 1.3 times the mass of Earth and sits in the star's habitable zone. This Goldilocks zone is the perfect distance from the star to allow liquid water to exist, which is crucial for life as we know it. Despite its close proximity to Proxima Centauri, Proxima B faces some pretty harsh conditions. Proxima B's harsh conditions. Proxima B, the exoplanet orbiting Proxima Centauri, is a strange and intriguing world, despite all the challenges it faces. For one, it's extremely close to its parent star, so close that it's bombarded by strong solar winds, which could potentially damage or even strip away its atmosphere. But even with these tough conditions, Proxima B still gets enough sunlight to keep its surface at a temperature that's not too different from Earth's, which means liquid water could form there. This raises the possibility that Proxima B could support some form of life, although it's not clear what that life might look like. One of the most interesting things about Proxima B is that it's tidally locked, which means one side always faces the star and is constantly bathed in sunlight, while the other side is left in permanent darkness. This creates a situation where the planet's day-night cycle is very different from what we experience on Earth. It's a bit like the Moon, which always shows the same face to Earth. Tidal locking can have a huge impact on the planet's climate, potentially creating extreme temperature differences between the day and night sides. The conditions on Proxima B, however, make it difficult to imagine life as we know it. The planet only receives about 65% of the Sun's energy that Earth does, which makes it seem less likely that life could thrive there. The temperature could swing wildly from scorching hot during the day to freezing cold at night, especially with the planet's exposure to harsh radiation from its star. Proxima Centauri is a red dwarf star, which is much smaller and cooler than our Sun, but it still emits strong ultraviolet and X-ray radiation that could be harmful to life. On top of that, Proxima Centauri has been known to send out solar flares, which are bursts of high-energy particles that could make life on Proxima B even harder to survive. One of the most concerning factors for Proxima B is that it's so close to its star that it could lose its atmosphere over time, especially if it doesn't have a strong magnetic field like Earth does to protect it. Earth's magnetic field helps shield us from the Sun's radiation and also keeps our atmosphere intact. But Proxima B's lack of a similar magnetic shield could leave it vulnerable. If the atmosphere were to vanish, the planet's surface would be exposed to space, making it impossible for any life to survive. Even though it seems unlikely, there are still some slim chances for life to exist on Proxima B. Some scientists have suggested that the planet's extreme environment might actually make it a good candidate for extremophiles, organisms that thrive in harsh conditions that most life on Earth couldn't survive. This would mean that if life does exist on Proxima B, it might look very different from anything we're familiar with. These organisms could be hiding out in the planet's atmosphere, perhaps deep beneath the surface or in the few regions that could offer protection from the harsh radiation. We don't know much about Proxima B's volcanic activity or the strength of its magnetic field, both of which could give us more clues about its potential to support life. The presence of seas on Proxima B makes it a more promising candidate for life, which only intensifies the search for advanced alien civilizations. Over the past few years, there's been growing interest in the possibility of alien life, partly because some people believe that more advanced civilizations might have developed technology to withstand the planet's harsh conditions. For example, it's been suggested that such civilizations could have constructed massive solar panels on the planet's sun-facing side to capture energy from Proxima Centauri, and then use that energy to power the dark side of the planet. Since the discovery of Proxima B, scientists have been eager to find out more about the planet, and they're racing to see if the planet will pass in front of its star in a way that can be observed from Earth. If it does, scientists will be able to measure its size, mass, and density by tracking its movement. What do you think? Leave your thoughts in the comments below, and if you liked this video, don't forget to subscribe to our channel. See you in the next one.